Hi, everybody. Welcome to March 14th, otherwise known as 3.14. For those who are celebrating Pi Day, like we are in our house, happy Pi Day. In this almost year together, and Glenn, you'll have to fill us in, when we began meeting, we've celebrated lots of happy times and been there to support each other for sadly many unhappy times. But Glenn, you have been the light, not just behind you, but you have exuded light for us the entire time. And we are, as I've said many times and will continue to say, eternally grateful for all that you have done.
Thank you very much. I'm glad to have been here for everyone. And I appreciate my time every week. I look forward to it.
Yes, as do we, your loyal listeners. So thank you to everybody who has submitted questions during the week. You've really been, as always, very helpful in crafting tonight's conversation. If you have questions during the conversation, please chat with me in the chat box privately, and I will do my best to weave your question into the conversation. All right, so let's get started. Glenn Grossman is an epidemiologist with over 20 years of experience. While pursuing his doctorate in epidemiology at UNC Chapel Hill, Glenn served as an epidemiologist on staff at the UNC Infectious Disease Clinic for 2 years and taught epidemiology and advanced analytics at Duke Medical School and at UNC. He has been involved in epidemiology forecasting and advanced analytics with Bristol Myers Squibb, Sanofi, Novartis, Medicare, Medicaid, the Veterans Health Administration, Military Health Service, CDC, this fabulous webinar for almost a year now, and other programs within the United States and abroad. As always, all views expressed today are his own. Glenn, how are we doing? What is going on around our country? You compared us earlier before the conversation to Chile. How do we compare to the rest of the world?
Thanks for the intro, Rebecca. Let me share this. Unfortunately, my favorite website that we've been going to for months shut down. Now that the CDC is doing better data and showing better graphics, the previous one that we've been looking at a lot is no longer in operation. So I have to switch over to the new way of looking at things now. So let me look at a high level here. All right, so we're looking here at the daily trends of case 7-day moving average. So what we're looking at here is we're on a really good downward slope from this most recent surge. This corresponds with the way we typically look at the seasonal flu. So cold and flu season is what the coronavirus typically emulates, and so that's what we're seeing here. There's a variety of reasons that the numbers have been going down, in addition to continued mask wearing and physical distancing and whatnot across the United States. There's also the seasonal stuff, and there's other reasons. It's just exhausting through much of the population, or the virus is just, there's not a lot of fresh meat for it to infect because of all the precautions people are taking. Unfortunately, right now you see that we're leveling it off at still a pretty high level. You can see that the level here that we're in now in mid-March is roughly the same level as the peak that we were on in the summer, unfortunately. So we're sort of like leveled off here. Luckily, we're not seeing a new spike. So the key thing that's going on now that we're thinking about are these two issues. The one are the variants that are increasingly spreading around the United States. And then the second is the people just have COVID fatigue, epidemic fatigue. And so a lot of people just don't want to wear masks anymore, physically distanced. And so what you get here is sort of like the average in the United States of both of these forces, the variants, or all three of these forces, the variants increasing, the epidemic fatigue setting in, and then the third is just the regular seasonal decay that you would see normally, just that this is normally a seasonal cold flu type of virus. All right, when you look at, let's look at deaths here. So deaths have gone down a lot, but they're also still pretty high. So when you compare relative to the summer, for instance, it's still at a higher level on average, but it's still continuing to decrease. So that looks good. I don't see hospitalizations here. I saw it over here. All right, so this is the New York Times. I like this. We can look at this on a county level. You can see that there's at the nation as a whole, there's a lot of yellow, which is good. That it means that the caseload is somewhat low. The problem is, whoops. The problem is some of these counties are quite high. So you see that like there's a few that stick out. One of the hotspots that we're looking at here is my computer's a little slow, is the New York City, New Jersey area, unfortunately. So right now, the state of New Jersey as a whole is the worst in the country. Where our cases are actually increasing. I'll go to that in a second. But it's not just New Jersey. You can see it's the whole New York City metropolitan area. And New Jersey is just part of this area. There's Long Island, New Jersey, this whole area is just not doing very well right now. New York City is also just not doing very well. However, when you look at the county level, you can see that there are a bunch of counties that are not doing very well in general. Texas has a bunch of counties. Hopefully these don't grow with the adjacent counties with their new guidance. But you can see that there's other counties across the country that are not doing very well now either. When you look at, let me see if I can get down there. So when you look at the states that are not doing very well, so New Jersey is leading the pack. New York, Rhode Island, in fact, what I just had was a better way of looking at this. This one. All right, I want to see state trend comparison. And so now what we're looking at is, let me get rid of California. All right, so now what we're looking at over here, whoops, I want rate. All right, so, oh, don't pay attention to Missouri. That's just bad data. So in fact, let me take Missouri off also. And let me add on, this is enough for now. So we can just make these comparisons. So if you see New York City was not doing very great. Oops. So New York City, it's still pretty high. It's coming down, but it's still, you can see it's still at a pretty high level relative to the other, at least the other states that we have on here. New Jersey is starting to go up again, which is not very common. Most states are going down or staying the same. New Jersey is inching up still, which is, it's a good thing that we're still pushing heavily for vaccination here, because our case rate is still going up, which is unfortunate. When you look at Florida, which has a high level of the UK variant circulating, luckily they're still going down. Texas is weird. So they got rid of the mask mandate. And so then they were going up a little bit. That was even before they got rid of the mandate. And now it's starting to go down a little bit. I don't know how much of this is due to testing or whatnot, but a lot of us are going to be paying attention to Texas and some of these others. One of the big advantages Texas has going for it is the seasonality of it. So right now, I mean, obviously they just had that snowstorm a bunch of days ago, but it's middle of March, and in Texas, the weather's really starting to get nice there. So people are spending a lot less time indoors just because it's more comfortable to be outdoors. And so just the seasonal variation alone, the weather explains quite a lot of that. All right, the other thing I wanted to show, I can just show it at a glance. Let me go back to New York Times. You can see that one thing that's very noticeable is a bunch of the states that are here are in the Northeast and that have been hit by the really cold winters that we're still experiencing. And so New Jersey, New York, Rhode Island, Massachusetts, you can see that a bunch of these states are clustered in the Northeast. Not all, but it seems like it's weather related for the ones that are up here. The ones that are high but going down tend to be some more southern states where the weather is a little bit further ahead than we are in the Northeast. And cases that are lower and staying low, there's a bunch of states that are doing pretty well here. And so these are states that were low and are staying low. And then that's pretty much it. The one other thing I'll point out here, so New Jersey is currently the worst. We have the highest rate per 100,000. And so we really need to work on that. New York City, though, if you compare New York City to, or some of the counties in New York to New Jersey, they would exceed the New Jersey average. So for instance, New York City exceeds the New Jersey as a state. Anyway, let's look at the variants. where am I looking? This is the good one for variants. So in the United States, here are the hotspots for the variant spread. So the UK variant, remember the UK variant is B117. What's interesting about this one is that it's around 50% to 70% more contagious. And in addition to that, it's around 60%, 50 or 60% more deadly. So that's why a lot of people are worried about the UK variant. It is protected by, if you get the vaccine does protect you from the UK variant. So this is really something of concern for people who do not have the vaccine yet. But there are some states that you can clearly see are at higher, like, or sort of these hotspots where there's a lot more UK variant in circulation. The 3 or 4 big ones are Florida, Michigan, Colorado, and California. Possibly also Massachusetts. Yeah, I would say Massachusetts as well. Then there's a couple in second place that you can see here as well. But so we're following it. However, when I pulled this up just a second ago, looking at Florida, where was I? Here. So we were looking here at Florida and Texas. Florida, you can see, despite the number of variants, we don't see it plateauing and we don't see it spiking yet. So this is really good news. When we look at this, all right, so this is a really interesting website, a page from the New York Times that they've been tracking. It was published on March 6th, looking at the spread of the UK variant. And so you can see that the UK variant is increasing rapidly across the United States. However, the cases in general for COVID are going down. So even though the blues are increasing here, overall we're plateauing because it was going down. The UK variant is increasing, so it sort of levels off over here. When you look at this a little bit more in more detail, this was looking at just how frequently we're sequencing. Some states really are not doing a very good job of screening for the variants, so we don't have as much visibility in there, but I'm going to skip over this for a second. I'll skip over that. So I like looking at this one. So you can see that the virus, that the UK variant, that's the one in blue, is really increasing in a bunch of states, but even as the COVID in general is decreasing. But because the overall numbers are still so small, you can't really tell very much. Like, so for instance, Arizona, you can see that it's clearly increasing despite all of our mask wearing and social distancing and everything. The numbers are still spreading at a higher rate. It's still increasing, and yet we don't see that over here in the data very much yet. In other, like California, it looks like it plateaued. California was shut down. They really took some heavy measures, and so it plateaued there for a while. And so their numbers are plateauing on average. Florida, you can see that the UK variant was spiking. And so even though, so Florida without the UK variant probably would have dropped a lot faster even, but because the UK variant is still spreading at such a high rate, the average between what the regular COVID without the UK variant versus with the UK variant is now making it look like it's flattening out, still going down a little bit, but not as fast as you would have thought. So it's a tug of war currently in a lot of states that have the UK variant. You can see clearly that the UK variant is still growing rapidly in the population. However, because of the seasonality, because COVID in general is going down, it's a tug of war in lots of states to see which is going to win. Is the UK variant going to increase faster before we get to summer and warmer weather, or will the COVID decrease fast enough that we won't see it? And so this is the basic tug of war. You see a lot of states that we're really looking at this right now. This is just another cool map that they provided. So B117, you can see that a lot of states are reporting the UK variant in it now. At this point, it's very ubiquitous. P1, which is the variant that's most common from Brazil, you can see there's a bunch of states, but not nearly as many. It does not spread as rapidly. It's not as contagious as the UK variant. However, it's expected to be around twice as contagious as the normal virus that we've seen. So we do expect some spread. But because of the seasonality and vaccination and other things we've been talking about, luckily it's hitting us at a good time that the caseload is going down in general. So it's hopefully not going to be as big a deal. The one caveat there is Brazil. I'll come to this in a second. Brazil, it's summertime in Brazil still, the end of their summer, and their cases are going up again. They really are getting hit really hard. A lot of people who were infected a year ago are getting reinfected now. And so because the new variant has broken out of their immune shields, their antibody shields, and so they're getting reinfected. And so it's really, this is what a lot of us are looking at. We're hoping, I think because we're vaccinating at such a fast rate here, a lot of us are anticipating that this summer will not look anything like last summer, that we'll be getting back to normal or near normal in a lot of different ways and our summer activities. But a lot of us are eyeing Brazil, and especially to see how the Brazil variant, this P1, impacts our vaccination program. And then I'll open it up to questions in just a second. The one other thing here is the B1351, which is the South Africa variant. It spread somewhat more than the Brazil variant. It had a little bit of a head start in the United States versus Brazil. It also, there's a worry about resistance to vaccination. We don't, the behavior is a little bit weird. There's a lot we still don't know about the B1351 or P1. Only that we can look at Brazil and see how crazy things are in Brazil. South Africa has been more willing to shut down. So because of that, it's a little bit trickier to see what the actual behavior is and to understand, but it's still also pretty dangerous there. All right, one other thing I'll just show you is this. So I also vaccination, I'll get into that and then we can open it up to questions. The first thing is, I'll show you the world map. You can see that the world map is not as dark red as it was at previous times during the epidemic. So seasonally, we're getting a little bit better, but there are some hotspots, particularly in Europe. Estonia is one of these global leaders now as a hotspot. Czechia, a bunch of others, Jordan over here. But you can see summer standing out. Brazil is this. They're in the southern hemisphere. This is summer for them. Their seasonality shouldn't be driving as many cases as we see. So something is really weird. A lot of us are paying attention to this right now because hopefully this does not pretend what our future will look like in our summer. A couple other things I wanted to just point your attention to here are one, so Estonia so Italy just announced that they're going to be locking down much of the country again. And the reason that they're locking down is because you see that there's a big spike that they're just having now. And so at the rate of spread, it's going to continue to increase unless they take extraordinary effort. And so that's why they're about to lock down again. Estonia is not taking as many precautions right now, so they really need to take a stronger effort to lock down. They have, I think people are being precautious, but not nearly enough over there. Brazil, as I mentioned, is still looking. When you look at the Italy curve and the Brazil curve, they're not so different. And Italy's about to lock down. Brazil's president has not been very good with their epidemic. He's not been a really good public health figure there. Israel is interesting. That's why I brought it up here too. Israel's interesting because they've been a global leader in whoops. I don't know why it's stuck there. Maybe if I go back here. Oh, there's a problem. Anyway, Israel was a global leader in vaccination, yet their caseload was still high. Let me see if I can reload this. Yeah. All right, so Israel, so here's the United States as a point of reference. So the United States, you can see we hit our peak and we're coming back down again. It's like not coming as down as fast as we were, but still coming down. But Israel still has almost, what is it, like twice the numbers as the United States does. And so that's despite the vaccination. So this is something that is still, they're coming down pretty sharply now because of the vaccines, but you can see that vaccines are not everything. And it's one of the reasons that despite the vaccines, we still have to be thinking about physical distancing, mask wearing, and all these other things. We'll talk about, the CDC just provided a lot more guidance on what people can do after they get vaccinated that we'll talk about in a little while. That was one of the questions that came in. And finally, the United Kingdom. This is where the UK variant was the most predominant. They shut down and they really got it under control. So that was the other one I wanted to look at. The one other thing before we open it up to questions, Becky, I just wanted to talk about vaccination. So Israel, 60% of the population has gotten at least one dose so far, which is great. And that's probably why the data that we're seeing over here, why Israel is starting to fall so quickly. It's just there are not as many people that are available who have no immunoprotection. because those are vaccines, then presumably some people were previously infected. So 60%, that means only 40% have not had any vaccine yet, and some of those might have been previously infected. So that means that that's the real reason it's coming down. But it's interesting that despite so many people being vaccinated, they still have roughly twice as many people infected on a daily basis as the United States. For me, that's still, I just find it astonishing. And then finally, whoops, where were we? Okay, and then the United States, we're at 1 in 5, as you pointed out a little earlier, are in the United States have had at least one vaccine. When we look at the 2 vaccines, so fully vaccinated, here's first a global map, which is kind of an interesting way of looking at it. The dark areas are the places that have been fully vaccinated, up to us. You can see what percentages we're looking at. Only Israel has gotten above 50% at this point. But here it is at a glance. Oh, so roughly 50%. Israel's at 48%. United States is at 11%. Some countries have taken a different approach. You'll notice up here, so United Kingdom, for instance, only 2.3% of people have had two courses, so 2 vaccines, 2 shots. Although in UK they call it jabs, they don't call it shots. But it's only 2%. Whereas when you look up here at UK, the number who've had at least 1 dose, it's, let me look at it as a percent. It is 35%. And that's because they're using the Astra Zeneca vaccine. And Astra Zeneca had done an additional analysis looking at the efficacy if you extend the length between the 2 doses. So if you give 1 dose, and then instead of giving it in 3 to 4 weeks, like we're doing in the United States with Pfizer and Moderna, if you extend it out many weeks into the future, then that means you can vaccinate more people more rapidly. And based on the evidence with the AstraZeneca vaccine that they have there, that's why UK and some of the other European countries are really rushing to vaccinate people with their first dose and pushing back the second dose a little bit there. The worry with doing that approach is that you might make it a little easier for new variants of concern to emerge, because the amount of immunoprotection per person is not as strong. But for now, that's not something they're as worried about. All right, Rebecca, let me open it up to you for questions. There are some interesting questions this week.
So you spoke about the immunoprotection, and Sid, if you could please unmute, had a great question about immunoprotection from the vaccine.
Yeah, hi. Thanks for all your help. My question is that do we have any information about how long the vaccine will be effective for? And if it's not going to be effective for a significant amount of time, will there be a booster, or will there be any effect on the variants?
Yeah, those are all good questions. So the short answer is we don't know for sure how long the vaccines will be effective. What we do know is that among people who are naturally infected, they typically do not easily get reinfected for 3 months, so 90 days. They're very, very well protected. At 4 months, around 10% of people can get reinfected, people who are naturally infected. And at 5 to 6 months, around 20% of people can get reinfected. After that, we don't know how long the persistence curve is, but we expect that, like when you look a year after natural infection, particularly with the emergence of the variants of concern and whatnot, I think that's one of the reasons in Brazil we're seeing a lot of people get reinfected. In some vaccines, like measles, if you get a natural infection, it's thought to protect you better than if you get the vaccine. However, the vaccine is sufficient that we don't typically have breakouts of measles, because the vaccine coverage is sufficient to give us herd immunity typically and prevent that. In contrast, something like tetanus, which comes from bacteria, the vaccine is actually much, much stronger than natural infection. The reason being, if you're infected with tetanus, the toxin that's produced, the dose of the toxin has impacts where it's strong enough to give you impacts for the disease of tetanus, but only gives you very, very, very mild immunoprotection going forward. So the vaccine in that case is much better than being naturally infected. And so we don't know where it's going to fit on this spectrum in terms of the vaccine being better, natural infection being better, or whatnot. Typically, one thing that we've talked about previously is that there's different types of antibodies. One type, there's a bunch of different types, but the two I tend to focus on for this disease are immunoglobulin A and immunoglobulin G. Immunoglobulin G is the one that we've been focusing on for the vaccines because that prevents severe symptoms, which is great. The problem is immunoglobulin A is what's most common in your nose and upper respiratory tract. And so that's one of the reasons that people might still be able to get infected even after they're vaccinated. The rates are very, very low, but it's a possibility. So we don't know for sure. Most people, because the antibody efficacy is so strong in these vaccines, we're assuming that the high amount of antibodies produced is going to be very strongly correlated with how long they last into the future. So we're pretty confident, but we don't know for sure. There are booster shots that are being evaluated in clinical trials right now for Pfizer and for Moderna. I don't know the other ones. I don't know right now off the top of my head if they're looking, but I'm assuming that they will be. But primarily, not just because of efficacy in general, but specifically because of the variants of concern. So because we're paying attention, we know that the Brazil variant of concern is out there, the South Africa variant of concern is there. They're making booster shots specifically for those. So it could be the case, but we're rolling out the vaccine at such a fast rate now. In fact, let me do that. I think we're doing 2.2 million doses a day was the last I saw. Not per 100, I want total. I think it's over here. Give me 1 second. Vaccines. So United States, we hit as of, what day is this? This is March. Oh, tell me what day this is. Whatever day this is the most recent data. Looks like it could be even today or yesterday. We hit over 2.5 million people vaccinated in a single day. And so the numbers, we can see that the rates are generally still going up. So that means that we're probably going to continue to hit these numbers every day, where it would not surprise me if within a week or two, we're hitting 3 million and maybe a month hitting 4 million per day. And so that's going to make a big difference. But because we're getting much better logistically, and a lot of the new vaccines like J&J don't need to be deep frozen in the same way, it could be that we just can start distributing the booster shots to your regular doctor's office. And so maybe when you would go in for your regular flu shot in the fall, you would just get a booster for coronavirus as well. And so I think that would probably be pretty logistically something that would be very likely at that point. Great.
All right, so it sounds like more to come, but thank you for that really thorough explanation, and thank you for that great question. Okay, let's move on. Let's talk about AstraZeneca. I know we've not been looking at AstraZeneca here in the United States, but is that correct? So far it's not been distributed, but you spoke about the AstraZeneca vaccine being the predominant vaccine in the UK. What can you tell us? Some studies, are there studies, or somebody mentioned that perhaps this vaccine can cause deep vein thrombosis or other blood clots or other conditions? Is that why it's not approved in the United States?
Yeah, this is a good question. A few people have asked me over the last week. And so basically, the AstraZeneca vaccine is being used heavily around the world, but not in the United States. And so, for instance, AstraZeneca is available in Canada and Estonia and much of Europe. And so much of the world has this AstraZeneca. It's also called the Oxford vaccine because that was where it was heavily co-developed. And so this vaccine, that's the one we're talking about in UK. The problem is that there is a lot of hesitancy now around using it. The reason is that in Europe, there were around 30 cases of people who were found to have blood clots after they got the AstraZeneca vaccine. Now, blood clots are very common among people, particularly among high-risk people who are taking the COVID vaccine. People over the age of 65, people with other comorbid conditions tend to be very higher risk for blood clots, and so that they cause deep vein thrombosis, that's DVT, pulmonary embolisms, venothrombosis, thromboembolism, VTE. And so the fact that there were cases does not surprise anyone, but it's making a lot of countries concerned to the point that a bunch of European countries have now stopped distributing the AstraZeneca vaccine. So for instance, as of this past week, Norway, Iceland, and Denmark stopped. Italy and Romania have paused the shots. And some other countries, Estonia, have paused some of the batches, but not all of them. So I think the reason is that, well, so first let me get into this, and then I'll get into what I think the reason is. So basically, in the United States, on average, one person dies of a blood clot every 6 minutes. And so the problem, so this is something that's just very common in general. So the problem is that in the United States, there are a lot of people getting vaccinated and then dropping dead of blood clots within days or weeks or months. And so the question is, well, was it due to the vaccine, or was it just simply due to the fact that blood clots are very common? And when you look at the clinical trials where you can compare people who got the vaccine versus people who did not get the vaccine, what you realize is that there was no difference in blood clots at all, no signal, no nothing. And in fact, when you look at the current rates that are being reported, 30 out of 5 million, those rates are no higher than the general population, according to the European Medicines Agency, which is similar to the FDA in some ways in terms of looking at this. And so as a result, there's not really any concern among epidemiologists. But these countries that are stopping are all democracies. And so if people need to get reelected, the politicians need to get reelected, and there's a concern among the citizenry, they need to demonstrate that they are concerned. And so the best way to do that is to put a pause on it, to an evaluation. Almost certainly what they're going to do is look at the people and say the rates are identical to the general population in terms of the rates of these of DVT and PE. So we should continue doing the vaccines. But it's tough, because you can imagine if they didn't pause it, when they run for re-election, their opponents might say, who are running for these government positions, could say, oh, these politicians, the ones who are in these current positions didn't care about the population. They didn't want to stop the trials, the vaccines, vaccination program. They were willing to let people die and put people at risk for this. And so because of the politics of it, I think that's the main reason why across Europe, we're seeing many countries at this point really struggling with whether to stop it, or they actually have stopped it for a period. I'm quite confident they're going to restart it at some point soon, because as far as I can tell, there's right now, there's no actual data to suggest that there's anything wrong, that there's anything about the vaccine at all that's causing any of these embolisms. So
so I understand the theory and the thinking behind this. So if all of these countries are now pausing delivering these vaccines, what happens to those vaccines that have been produced? Do they expire? Are they just fully wasted, or can they continue to freeze them until they have more information? What happens?
Yeah, that's a really good question. I don't know. I suspect, so there are a lot of countries that are still vaccinating. So they might be redistributed. And so maybe they just won't distribute as much to those countries. Maybe they're just being kept in the freezers and they'll be fine. I don't know how long this is going to go on in terms of this, this review. It could be that it just lasts a week. And so in a few days, they say, okay, we're going to start vaccinating again. In that case, I wouldn't care about the shelf life. I think that for most of these, I'm not really that worried about this idea of the shelf life. It could be, but I'm not worried. My bigger concern is that COVID is a very serious disease that's killing lots and lots of people around the world. And if they're delaying the rollout of the vaccination, then that means that they're continuing to keep these people who are at risk and without getting the vaccine. And so for me, that would be the biggest thing, that each week delayed are people that could be getting vaccinated and are not getting vaccinated. The one other thing, so the question is, why hasn't AstraZeneca been approved in the United States? Which is a good question. And the reason is that the clinical trials for the AstraZeneca vaccine happened to end earlier in other countries in the world. But the clinical trial in the United States wasn't able to enroll enough people quick enough to see the results. And so as a result, our clinical trial is still ongoing in the United States. And so it's probably going to close out in another few weeks or so. And so that means that the reason it hasn't been approved is the clinical trials aren't done yet in the United States. There's no other reason for it.
All right, that makes sense.
Yeah.
We'll take that. Another question about just COVID vaccines in general. A question about, can people who are pro-life take the COVID vaccines? Were aborted fetuses used to create the vaccines? And what is the controversy all about? What are your thoughts here?
Yeah, this is a really interesting question. I hadn't even thought about this before I looked into it. But so apparently over the last couple of weeks, there's been a major controversy in some communities looking at the vaccines and about whether people who are pro-life should take the vaccines, to the point that there was a formal denunciation put out by the Catholic Archdiocese of New Orleans and later joined by Catholic bishops nationwide in the United States. And so this is crazy, I mean, from my perspective. But when you dig into it, it's kind of interesting. It's the same, and so basically it's the same kind of idea with the Holocaust. This is a medical ethics question that was put to me in my epidemiology doctoral program, which is part of like just medical ethics training. And here's the question. So in the Holocaust, the Nazis did unethical experiments on Jews and other people who were victims of the Holocaust. As part of the medical research that was unethical, they found interesting findings. The medical ethics question is, should physicians and should the medical community use the results of the scientific experiments that were conducted unethically during the Holocaust? Or should we just ignore them completely? And the reason is, so the two ways of arguing it are, well, some people say, well, maybe if you use the results, then people's lives, they wouldn't have died in vain because of the results that you find. And then alternatively, you might say, well, if you use the results, then you're only incentivizing this kind of behavior in the future. Whereas if you don't use the results, then anyone who does these kinds of unethical experiments in the future will know that it's unlikely that anyone will ever look at their work. And so it's almost a way of disincentivizing it in the future. And so our current medical community globally has determined after the Holocaust and the Geneva Conventions that we should not use any of that research or medical findings that came out of the Holocaust, for better or for worse, but that was the conclusion. So how does this impact this? So it turns out that with the vaccines, so they're specifically, so there's two things going on. It turns out that the Johnson & Johnson vaccine and also the Astra Zeneca vaccine as it matters. So the Johnson & Johnson and the Astra Zeneca vaccines use cells that originally came from fetal tissue. So the way that it worked was around 50 years ago, there was originally fetal tissue. And why were fetal cells used? Because it was easier to keep those cells alive in the lab. The adult cells were dying. So 50 years ago, the fetal cells were the ones that were, the aborted fetal cells were the ones that were used. But since then, lots of clones have been made. So it's been 50 years at this point. And so all of the cells used in the decades past are no longer the same cell. They're offspring, essentially clones of the original cell. And so that cell, it's sort of, we sometimes say that they're immortalized because now that they replicate or they can reproduce and we can continue using them in the lab, they are not directly, let's say, pulled out of a aborted fetus or anything in terms of making the stuff. However, they're part of a line of cells that did come originally from it. In contrast, the Moderna and Pfizer vaccines, they are mRNA vaccines. They don't use cells at all. However, in order to test the efficacy of the vaccines before they put them in people, they tested them against these cell lines as well. And so then the question is, are these ethical? So the J&J and AstraZeneca actually use the descendants of these cells. It's part of the construction of the vaccine. And then the Pfizer and the Moderna vaccines used it as part of the testing process, but not in the actual shot that you get in your arm. And so it's an interesting question. And it's related to the Holocaust question too. It's kind of this larger question: can the ends justify the means in terms of this healthcare? And so here's the current thinking for people who are pro-life in terms of the thinking of it. So like I said, the AstraZeneca and J&J vaccines, they have no fetal tissue in them. It's not the case where they're like literally taking aborted fetuses and grinding them up and shooting it at people. Instead, it's not that at all. It's just sort of descendant lines from that, and where the cells were from 50 years ago. So it's sort of just like clones that have been worked on over many decades. The mRNA, like I said, the Pfizer and Moderna, the cell lines are not part of the shot in any way, except that they were tested on them originally before we put them in people. And there are other common vaccines out there that are the same way as the Astra Zeneca and J&J. So for instance, if you've ever gotten a hepatitis vaccine, chickenpox or shingles vaccine, those all use the same cell lines from the 50 years ago that we've been using across all these vaccines. And so this is basically where we're standing. For what it's worth, the Pope has come out and said that people should use the vaccine because it's really important to save lives, that more people should get vaccinated. And the biggest conclusion that I saw that I thought was most interesting was the Ethics and Public Policy Center that looked at this, looking at pro-life scholars that were looking at this. They said that it's not simply a question of the ends justifying the means. They said because the cell lines are so remote and so attenuated, that the connection is so remote and attenuated to abortions that were performed 50 years ago, and that there's no incentive, that because of this, there can be no incentive for future abortions. Because it's the same thing in the Holocaust, where they said, okay, we shouldn't use the results because then we don't want to incentivize people doing medical experiments unethically in the future. That's the same thing, that there's no incentive to abort fetuses in the future to make vaccines as a result of the way these are made. So as a result, there are no moral reasons against accepting the vaccines. So that's basically the idea here. So right now, it's a controversy among a lot of pro-life people, but hopefully this is putting it to rest. It should not be a reason to not get vaccinated. Great.
Thank you, Glenn.
Question.
That was really informative. Thank you for clearing that up for us. So just on another question regarding the vaccines, right now the Moderna and the Pfizer vaccines are given, I believe, to 16-year-olds and up and 18-year-olds and up respectively. I might have that in reverse. Do we have any information about how the studies are going for the vaccines for children?
That is a really good question. So yes, thousands and thousands of children have been recruited into these studies to see what the infection rates look like after the vaccines and the symptoms. Luckily, symptoms in children are so low that the risk, so whenever you do a treatment or a vaccine, it's always a question of the risks versus the benefit. And for such a low risk disease for kids, the risk benefit is different. And that's the reason why we've had this delay to begin with, and why it was the over 16 or kids over 18 or people over 18 that originally were eligible for the vaccine, just because the risk benefit didn't make sense at that point. Now that we'd like to roll it out more for things like herd immunity, that kind of whatever, this concept of herd immunity, it would be tough if there was a risk to kids. You wouldn't want to put that risk on kids simply for the sake of adding additional protection for grandparents and adults. I mean, obviously we don't want grandparents and older adults and higher risk people, immunocompromised people, say, to get sick. But if there was an undue risk on kids, that would not be sufficient. So there also has to be a sufficient benefit for kids themselves to justify it. And so that's what's being evaluated now. Thousands of kids have been recruited. I don't know when they're going to report out. It's not going to be within the next week or two. I think we're looking at months. It all depends on how quickly they get infected. The quicker people get infected, then the quicker the enrollment gets filled up, and you can see the results of a vaccine test like this. So I don't have any more information than that. Oh, with the one exception, here's one interesting thing. So this, I was going to point out, I want to look at the US. All right, so this I'm looking at is age. Oh, I was just looking at this. Let me see if I can find it. Maybe demographic. Yeah, here it is. So I think you're going to find this really interesting, this right here. All right, so let's look at what this is telling us. This is from the CDC's website. their data tracker. They've really improved their data a lot since the Biden administration came in terms of what they're reporting and what you can find here. So I'm going to be, in future weeks, I'm going to be referring to this at the CDC site a lot more. What we're looking at here is the rate per 100,000 people. So among each age group, the rate of infection. And so what you can see is the green dotted line, which is the 18 to 24-year-olds, are getting infected at the highest rate. So 18 to 24-year-olds are really spreading this disease over the last peak. So this was, you can see we're in March. The data is not as good here. So I wouldn't pay as close attention to this just because the data is a lot more weak here. But you can see it at a high level that the green dot, the 18 to 24-year-olds, were really spreading it a lot. Next after that were the green dash lines, the 25 to 34-year-olds. And then directly after that were the 35 to 54-year-olds. So you can see who's really spreading it. When we're talking about kids, these are the yellow dotted lines here. These are the 0 to 5-year-olds. And then the dashed line are 6 to 13-year-olds. So you can see, even during our seasonal cold and flu period, and what we're seeing is the seasonality for COVID-19, the kids did not get it nearly as much as anyone else. And this is astonishing because the kids were in the same household as the parents. The kids were still at risk as everyone else, and yet the kids were not getting infected at the same rate. There's a bunch of reasons why this could be the case. For instance, we knew originally that kids generally had less ACE2 receptors. There were a variety of other possible explanations, but it should hopefully let parents' minds at ease to know that kids, despite the outbreaks around the country, I mean, where people weren't wearing masks and whatever, that kids under the age of 14 really were not getting infected very much. People over the age of 14, the 14 to 17-year-olds, were getting infected, not as much as like the 25-year-olds, but they were getting infected a lot more. So they looked more like older adults. But the kids, typically the prepubescent kids under age 14, were not getting infected at a high rate at all. So even with the vaccines, when they come out, it's not as imperative as when we're looking at the vaccines for the older folks.
So I think that kind of answers to a degree our next question about kids going back to school and the risk that poses for their parents and grandparents who live with these kids. So I think you've sort of answered that to a degree, but I have a feeling you have more.
Yeah, there's a couple more slides because it's a particularly interesting question. So here's the question. I'll restate it. Can you tell us more about the increased risk for parents if their kids attend primary school in person? So the kids go to school, the parents are working from home still because they don't want to get sick. And now what are the parents' risks, not that the kids are going out to school? And so this was actually looked at a county level across the United States. Here, I'm just showing this briefly. There's nothing too interesting on this, but the things to look at are, at a county level, you can see that some counties had more mitigations, that some counties took more precautions than other counties did. Some had more in-person classes, were more likely to have in-person classes than other counties, and some had full-time and some were more part-time. All right, so when you look at this, you can see there's wide variation across the country in terms of how the counties dealt with the epidemic. So let me cut to the chase. And so basically what you find is that once you institute 7 or more precautions or remediations in the school, including mask wearing, including the things we'll go through in a second, it gets down to no difference versus the kids not going to school in terms of the parents' risk. So the parents are at slightly higher risk if the kids attend in person and have 0 remediation. So for instance, if the kids attend in person and don't have to wear masks and don't have physical distancing and don't have any remediation at all, then the kids actually are more likely to get infected and are more likely to infect the parents. But once you start doing these additional precautions, then it very rapidly goes down. And what we have here is strong evidence that you actually have no greater risk of getting COVID even after the kids attend the school full time. So specifically, let me just go down. There are some remediations that are more than others. So the ones that they looked at were the students wearing masks, the teachers wearing masks. So if you have everyone wearing masks, that counts as 2 remediations. So remember, the 7 was the magic number here. But so that you can see that some were more important. The teachers were actually more important for them to wear masks than for the kids to wear masks. And the reason is, and it goes back to what I was just showing you, one reason is that the kids are just simply not as infectious as the adults are until you get to the 14 to 17-year-olds. But the other reason is that the teachers are the ones who spend most of the day talking. And so it's actually the case when you look at a lot of the schools that one of the things we're finding now is that teachers are actually more likely to spread it to other teachers. So for instance, teachers for a while were worried about going to in-class schools again, back to elementary schools, because they didn't want to get sick. What it turns out is that the teachers are mostly not getting infected from kids. Quite the contrary, the teachers are getting infected from the other teachers. And so it's really critical that the teachers wear the masks, because that's going to be one of the most important things that they can do. If they go into their classrooms and there are no other teachers there, that's actually safer for the teacher than going to the teacher's lounge in between the class, between the students, and sitting in the teacher's lounge for lunch. That's where they're getting infected. You can see that some things are less effective. So for instance, desk shields, like those plastic shields that people were putting around desks, were less helpful. Other types of things were less important, the part-time versus full-time. But you can see that some of these were more helpful. You can see that the ones listed here, putting extra space, restricted entry, no supply sharing, put the same students, reduced class size, like these had a pretty big effect. Screeners, daily symptom screeners had a big effect. No extracurricular activities had a big effect. You can see that some were a little bit more impactful than others. But you can see that these two things were the big insights: the 7 or more precautions and the specific ones. One other thing I'll just show you before we move on to other things, because I've talked about this a lot, is you can see that there's wide variation for each of these things by county across the country. So even if you're looking at student masking, it's a little bit hard to see. Let me make it a little bit bigger. But you can see that student masking, let me make this front to front, is higher in some counties than in others. Restricted entry, extra space. You can see that this varies across counties in the United States, which is so interesting, that it's because it was sort of every state for themselves and they all had to make their own rules. And it was even a lot of counties and a lot of schools making rules for themselves. There's wide variation across the country in terms of the precautions that were actually utilized. It's just fascinating. But the big takeaway is that students can go to school safely if they do these precautions, and that really they don't even have to do every precaution. If they hit the magic number of 7, then it's as if they are that there's no additional risk for the parents, which is good news.
Fascinating. Lucky 7, or 7 not lucky. But usually we like number 7, right? So Debbie Weisletter, if we could ask you to unmute, please. You had some great questions pertaining to masks and behavior of different age children.
Hi, Glenn.
Hey.
Can you hear me?
Yes.
So I have a 2-part question. The first one, I know you were looking very closely at Florida before, and because you're the guru, I've also been watching Florida, and you see on the news how spring breakers and everybody's there. Is that still something that we're looking at closely and as concerned? Because if you look at the graph, it didn't look like it was as much of a concern.
Yeah. So there's a couple of responses. That's a really good question, first of all. So let me answer it in a few ways. I have to keep track of these. So the first thing is, when you're look at who's getting sick, we're about to have a flood of people during spring break in Florida who are specifically the 18 to 24-year-olds, the dotted lines, who are the most likely to spread it. So that's one of the reasons that we're concerned in Florida that you might see a spike. The thing about Florida is a lot of people come from out of state and then go back to their states and spread it. So the worry is that we're going to actually see a bigger spread of the UK variant as a result that comes out of that. And that is a little bit worrisome. The other thing is that seasonally, it is cold flu season, that what we're talking about for coronavirus. In Florida, the weather is getting increasingly nice. In Florida, it's sort of the opposite of the Northeast, where in Florida, in the winter, it gets very nice outside. People prefer to spend time outside, whereas in the summer, it gets hot and humid. And so that's when they like to go inside with the air conditioning and spend less time outside. So right now, it's pretty comfortable. And so because of that, I think that's largely explaining why, oh, and plus people are getting vaccinated and whatnot. I think that largely explains, where was I to see Florida? So I think that largely explains why Florida is doing so well right now. I think Florida was over here. So Florida was high, but going down. And so I think that's what explains it. They're not going down as fast as some other states are. And I think that's largely because of the UK variant. It's that's basically what we're looking at there. I don't know if I answered your question, but that's basically what's going on in Florida. We're
You
paying
did.
attention.
There was another part of the question, and that was across the country, because a lot of states are changing their regulations. How do we expect to see the rest of the country with, you know, the mask mandates being negated and a lot of that? Is that something that we can expect to see more cases and more spikes in all those places?
Yeah, that's a really good question. So it's a race against time. So there's a few things that are competing with each other. The first and foremost, I would say, is the seasonality of the disease. Even without mask wearing, without physical distancing or anything, because we're now leaving, it's already the middle of March, we are on the downward side of cold and flu season in general. And so as a result, last year was highly unusual because it was a novel virus. And so because no one had any immunity at all, it was just going, we had that first wave that just started in March and went through April, May in a lot of the states. And then we had a summer wave in a lot of the states as well. But we're not expecting to see that going forward, at least for this year, because of the seasonality of it, where it's going to be, we expect it to be much more similar to a typical cold and flu type of seasonality for this virus. The second thing is, so that's one, that's the most important thing right now. The second thing is the vaccine rollout. The third thing are the mask wearing, the physical distancing, keeping that step up, which I think a lot of people still are. Even though the mandates might be going away, a lot of people are still wearing the masks and are still paying attention to the CDC guidance. And then fourth is the variants and the rise of the variants. And so those things are all competing right now. And so what we're basically seeing when we look at the national average is it is an average of all those four things. I don't have a picture of that right here, but it's basically an average of those four things that we're looking at. Anyway, and so yeah, I don't know which will win. I think ultimately, we're quite confident that whatever impact it has, we're heading towards summer, and we just typically do not see much cold or flu during the summer. And I think this year we are not going to see the same kind of peaks that we saw the summer of last year. I think it's going to go way down simply because of the seasonality. Plus, we have a lot of protective immunity. The vaccine rate is going way up. So I think that we're going to continue to see this downward trend. It's just a question of whether we plateau for a little while or whether we just continue down. And that's still the open question.
Thank you, Glenn.
You're welcome.
Great
Hey,
question,
Rebecca.
Debbie. Thank you.
Rebecca?
Yes.
So I know we're at about time, but why don't we ask, there was new CDC guidance that just came out that a lot of people might be very interested in about
Yes.
now that people
Please.
wanna,
I think that's a great way to end our program tonight with the new CDC guidance. Are you speaking about the guidance for specifically for folks who've been fully vaccinated? And yes, you are. Look at that. So let's end there.
I found this very happy vaccine cartoon, so I put that in here. So among people,
We like it.
among people who have been vaccinated, this is for you, and for people who will be vaccinated within the next month or two, this is going to be for you too, although the guidance might change. Here's the current guidance that was just issued over the last few days by the CDC. So this, first of all, it only applies to people who are fully vaccinated. What does it mean to be fully vaccinated? That means 2 weeks after the second dose of either the Pfizer or Moderna vaccine. So it's not when you get the second dose, it's 2 weeks after getting the second dose, or 2 weeks after getting the 1 dose of the J&J vaccine, because the J&J vaccine is just 1 dose. So it has to be 2 weeks after the final dose. If it has been less than 2 weeks, you're not fully vaccinated. So it doesn't apply until you're 2 weeks after. All right, so that's the first thing. All right, so here's the guidance. At a high level, let me just say what it is, and then I'll show you, go through some examples. All right, so if you have been vaccinated, fully vaccinated, 2 weeks after the last dose, you can hang out indoors with other vaccinated people who are also at least 2 weeks after their last dose, so are also fully vaccinated. So fully vaccinated people can hang out with other fully vaccinated people, they should still avoid large numbers of vaccinated people. So we're talking about a few, but not, but a fair number that can hang out. So this is a pretty revolutionary change. So people who are fully vaccinated can hang out indoors without a mask now. That's huge. So this is great news for them. The second new thing is that people who are fully vaccinated can hang out indoors with a single household. So if there are unvaccinated people from a single household and no one in that household is at high risk, then they can hang out without a mask as well. So this is also revolutionary. And then third, previously, if you found out that you were in the same room with someone who developed COVID-19, you would typically have to self-quarantine for 10 to 14 days. And now, if you have the vaccination, if you end up being near someone who ends up having COVID-19, you don't need to self-quarantine for those 10 to 14 days. However, there are a couple of exceptions to that with all of these that I'll go through in a bit more detail in just a minute, because the exceptions are the key things here. With this one, the exception is that if you develop any symptom at all, a sore throat, a cough, fever, anything at all over that period, then you immediately need to self-quarantine and get tested. And so that's the new guidance. All right. So what does this mean? All right. So the first thing I said is the bubble. Now that anyone who's been vaccinated, fully vaccinated, I mean, they can sit inside without masks together, which is great news. All right. The next thing is, if someone is fully vaccinated and they want to see their grandkids or they see their families that they haven't seen in a while, they can hang out with a single household without masks now, without fear. That's great. However, let's start looking in the weeds of this. If a grandparent on one side of the family wants to visit the family, and a grandparent from the other side of the family, so the spouse's parents are unvaccinated, if the unvaccinated parents leave the house for a few hours so that the vaccinated parent can come in, is this okay under CDC guidance? And the answer is no. The answer is, if there's someone who lives in the house who is at high risk and is unvaccinated, even if that person leaves the house, they should not meet together because they're still at high risk. All right, let me go through some other exceptions as well. All right, so you should still take precautions, the normal precautions you would normally do. If here's some reasons. If you go into public at large, if you gather with unvaccinated people from more than one household. So if people live in 2 different apartments or 2 different houses, then you need to wear masks. You can't go without the masks. Another reason, if you don't know the vaccination status of people, then that's another reason why you should assume that they're unvaccinated and wear the masks and social distance. It's the things we've been talking about that you should be doing. The other thing, if you're visiting with an unvaccinated person who is at increased risk of severe illness, even if it's one household, if they're at increased risk, or they live with a person who's at increased risk, even if they're not there right now, then the same thing. You need to wear the masks, physical distancing, and everything else applies. You should still avoid, so again, that people who are fully vaccinated should still avoid medium or large size gatherings. So the question is, well, can they now wear masks and go to a bar? Or can they now wear masks and go to a concert? The answer is no. Even if you're vaccinated, you should still avoid medium or large size gatherings in general. All right, you should still delay domestic and international travel. So again, what does this mean? It means if you are vaccinated, fully vaccinated, you should not be doing long distance travel. You can get in the car and travel to hours to get away, but you shouldn't be doing it really long distance travel. You shouldn't be doing much travel at all right now until more people are vaccinated, until we really get a better handle at it. The caseload is just still too high in much of the United States. This is the reason why it's sort of like partial guidance right now of what we should be doing. As we approach summer, these restrictions are almost certain to change, and we'll have more that we can do after you get fully vaccinated. Other things, let me just continue going down this list. you should watch out for symptoms of COVID-19. Remember that the vaccine is extremely effective at preventing you from needing to go to the hospital. However, it does not completely prevent you from getting infected. And so you could get infected and could have symptoms, and you don't want to get other people around you infected if you do get symptoms after you get the vaccine. So you need to be attentive and make sure if you do have any symptoms that you don't expose anyone else and get them sick. Because just because you have the vaccine doesn't mean that someone who's not vaccinated is going to be safer. And if you do have symptoms, I would stay home and self-quarantine. Do not wear masks out with people and think because you have a vaccine and you have symptoms that the mask is enough. I would just stay home. You don't want to put anyone else at risk. And whatever your guidance is at your local workplace, if you need to go to work, if your local workplace says that you need to wear masks, then you have to wear masks, regardless of what the CDC says. And so there's still a lot more that we're learning. The question that Sid asked earlier about how long will it persist is one of the things we're still trying to figure out. We're still trying to see how many people get infected. As more, there are new studies that keep on coming out. It's still not clear, but it seems like it's getting more and more likely that the infection risk is not high. So that's really good news. So we can talk about that a little more next week. And so the CDC guidance is likely to be updated. But for now, the key takeaway are these two things. Under the very unique circumstances, if you're in a room only with people who are fully vaccinated, you can rip off those masks and enjoy. You are clear. And again, if you want to see the grandkids that you haven't seen in a year and you're fully vaccinated and they are low risk and there's no one high risk in that household, take off your mask, go and hug them. You are safe. And so that's it. But there are a lot of exceptions. You don't want to get people sick. So please pay attention to the exceptions that we discussed.
All right.
Becca.
But if you do take off that mask, keep it nearby. Don't start burning your masks that you're waving around, Glenn. Right?
That's
Keep
right.
it nearby.
Don't burn your
You are
mask.
going to need it, and for quite some time, right?
That's right.
Okay, well, these pictures are very helpful, Glenn. I don't know about everybody else, but I love your visuals. You're a happy vaccine dude, and these bubble pictures. You really take
There were
this
some.
very, very seriously, and we appreciate that.
I look online to see where I could find the best ones. This came from a CDC website originally, which wasn't very good. Like I didn't like the way that it looked like green and green are vaccinated and what households could be together.
Yeah.
And then I found on a different CDC website this stuff. I
Much better
visuals that can help to describe it. And there were a bunch of websites I went through to try to find. I think these were the best that I was able to find.
Much better. These are stuck in my brain now. So
Yep.
Excellent. Okay. So maybe next week you can tell us a little bit more about your thoughts about going to an outdoor concert this summer, maybe in a stadium or maybe not. Can we maybe do fun things like that? Perhaps. Just saying.
Yeah,
But anyway.
I'll have a better answer later, and we don't know for sure. We're gonna have to be paying close attention to the variants of concern. But I think a lot of us are very optimistic that we're going to have a July 4th this summer that a lot of us can enjoy outdoors with the July 4th barbecues. And I think a lot of us are optimistic at this point. We'll see as it gets closer, but based on the vaccine rates that we're doing and the summer in general, I think that a lot of us are very optimistic for July 4th.
All right. So start getting your briquettes, your propane ready. Let's hope we can have some fun times together. And with that, I think we will leave it. So many more great questions. We will resume next week, same time, same place. We'll all be a little bit more used to the daylight savings time by then. But keep sending in those questions. And Glenn, keep showing us these great visuals. And everybody be safe, be well, have a great week, and we'll see you next Sunday. Take care.
Thanks, Rebecca. Thanks, everyone. Bye-bye.